Alright, so in this video I want to show you how to multiply matrices. We kind of talked about that in the last video, but we did something called scalar multiplication. In this example, or in these examples, we're going to talk about actually taking two complete matrices and multiplying them together, which is a little bit more involved. Okay, so there's really two things you have to keep in mind before actually multiplying them. First, it's not always possible to do it. And here's kind of how you tell if it is possible. The number of columns in the first matrix has to equal the number of rows in the second matrix. So here's what I mean. Let's suppose that matrix number 1 had rows by columns. That's always how we write it, by the way. So I'm just going to write that, rows by columns. Let's suppose it had 3 rows and it had 10 columns. And then matrix number 2, a different matrix, let's suppose that it had its rows by columns. Okay, let's suppose that it had, I'm just thinking here, let's say 2 rows by 3 columns. Okay, in this case, it says the number of columns in the first matrix must equal the number of rows in the second matrix. So the question is, could we do matrix 1 times matrix 2? And the answer is no, that's impossible. Because the number of columns here is 10, the number of rows here is 2, that doesn't work. However, and this is important, we could go the other direction. Okay, matrix 2 is a 2 by 3, matrix 1 is a 3 by 10. This number of columns equals that number of rows. So this is possible, and that's important to know. The order is important when you're multiplying matrices. It's not like that with numbers. This is impossible. You could actually do this. It doesn't work like numbers. 2 times 3 is the same as 3 times 2, and we don't care about the order. With matrices, we do care. Okay, now you might be confused, why do the rows have to match up with the columns, and that will become more clear when we do a couple examples in just a sec. But let's practice first of all with these 4 examples down here, deciding is it even possible to multiply it. And then the second point is this: the dimensions of the new matrix are going to be the rows of the first matrix by the columns of the second. So here's what that means. If you look at A right here, first of all, if we were doing it in this order, if we were trying to do this matrix times this matrix, is it possible? And the answer is yes, this is possible, because the columns of this one are equal to the rows of this one. Basically, these inner numbers have to be the same. That's the first step. Is it possible? The new matrix is going to have the following dimensions: the outside numbers, the rows of this one, by the columns of that one. So the inside numbers, the 2 and the 2, tell us if it's possible. The outside numbers tell us what the new dimensions are going to be. So this new one will be a 3 by 4. Try to pause the video and see if you could answer the same 2 questions for B, C, and D. Number 1, is it possible? Number 2, what are new dimensions going to be? Alright, so on B, you might be tempted to say, well, 4 by 5, 4 by 5, that's the same dimensions. It seems like it's possible, but it's not, because this is 5 columns, that's 4 rows, so it's impossible. That means we're not even able to multiply those. Okay, option C, this is 8 columns, 4 rows, that's also impossible. We can't do it, because the columns right here have to equal the rows right here. And then this one is possible because these numbers are the same. What are the new dimensions going to be? The new dimensions are going to be 1 row by, sorry, that's supposed to go over there, 1 row by 2 columns. That's the new dimensions. Alright, so now I want to show you how to actually multiply these. We'll do 2 examples. One is just a simple matrix, and the other is actually a word problem, something where you might, in theory, use it in real life. Alright, so first of all, let's decide if this is possible. This has 1, 2, 3 rows, and it has 1, 2 columns. So 3 by 2. Columns are the ones that go, think of the columns on a building. They're kind of the tall pieces of it. This part right here, this one has 1, 2 rows, and it has 1, 2 columns. So that's a 2 by 2. So we have a 3 by 2 times a 2 by 2. Is it possible? Yes, because these numbers are the same. What are the new dimensions going to be? They're going to be 3 by 2. So here's how I like to do it. I like to write a blank 3 by 2 matrix and then just fill it in. So we're going to need, let me actually do this in black because I'll use different colors for each of these. Okay, so I'm going to fill in a blank, that actually probably going to need some more room also. A blank 3 by 2 matrix, and I'm going to show you how to fill this in to hopefully make it make sense. So blank 3 by 2, so we need 1, 2, 3 rows, and we need 2 columns, and that's what that looks like right there. Okay, here's how you do it. So right here, this red one hopefully you would agree with this, that is in the first row and the first column of this new matrix, right? First row is right here, first column is right here. First row, first column. So how do I do this? I take the first row of this one and I multiply it by the first column of this one. So I'm going to do -5, the first number here, times 4, the first number here. -5 times 4, which is -20. And then I'm always adding the entries. And then I do -2 times +1. The second number in this one times the second number in this one. So -2 times +1 would be -2. So that means our first number here, -20 plus -2, gives us -22. Okay, so that was first row, first column. I took the first row here and I multiplied by the first column here. This one right here in green, this is the first row, but the second column. We're the second column right there. So I'm going to circle the first row in this matrix times the second column right here. So we'd have -5 times +3, because I'm multiplying each number that matches up. That's -5 is the first number here, 3 is the first number there. -5 times 3 is -15, plus, it's always plus. -2 times -1 would be +2. So -15 plus 2 is -13. That's the first row, first column. Now you might be able to tell why it would be impossible to do this if the dimensions were wrong. So suppose that instead of a 2 by 2, suppose that was a 3 by 2. So you actually had a third row. If you had some third row of numbers here and you were trying to do -5 times -2, you'd have to do -5 times 3, -2 times -1, and then there would be this third number down here that has nothing to match up with in the first matrix. So that's why it's impossible to do it unless this number and this number are the same. All right, now we need to get what I just put in blue right there. That is second row, first column. So I'm going to circle the second row here and the first column right here. 2 times 4 would be 8. 3 times 1 right there would be +3. So 8 plus 3 is 11. Okay, then we are going to do second row, second column. So I'm circling the second row times the second column. 2 times 3 would be 6. And 3 times -1 would be -3. 6 plus -3 is 3. Try to pause the video and see if you can fill in that last row on your own. And then when you're ready, hit play. So this right here is the third row, first column. So third row times first column. 6 times 4 would be 24. And -6 times that +1 would be -6. So 24 plus -6 is 18. And then finally we have right here, this right here that I just underlined is the third row, second column. So I'm circling the third row here, and I'm circling the second column there. 6 times 3 is 18, -6 times -1, +6, and 18 plus 6 is 24. And that is our final answer right there. When would you use this in real life? Possibly not too often. I mean, it's definitely used in other higher level math courses like linear algebra. But here's an example. Here's a word problem of when you might, in theory, use this in real life. So we're talking about a track meet where first place runners get 10 points, second place gets 5 points, and if you finish in third, you get 2 points for your team. We have 2 teams competing, the Flying Falcons, who had 5 in first place, 6 in second, 4 in third, and then the Running Cheetahs had 7 first place, 3 second place, 9 third place. Who won the meet? How many points did each team score? So let's draw a matrix for each of these. So I'm going to call FF, that's the Flying Falcons, and they had people that came in first, second, and third. And then the Running Cheetahs, we'll call RC, they had people that came in first, second, third. And here's how you could do this. You could multiply this by the point values for first place, second place, and third place. So first place, it says up here, gets you 10 points. Second place gets you 5, and third place gets you 2. Okay, over here we want to see how many people did each of these teams get in those places. So Flying Falcons had 5 people in first place. That's why it says right here I'm putting a 5 under first place. And the Running Cheetahs had 7 people in first place. Flying Falcons had 6 in second place. The Running Cheetahs had 3 in second place. And then finally the Flying Falcons had 4 in third, and the Running Cheetahs, it tells us, had 9 in third. Okay, let's see if this is possible. This is a 2 by 3 matrix. It has 2 rows and 3 columns. This has 3 rows and 1 column. So because these numbers are the same, we can multiply, and the new matrix is going to be a 2 by 1. So I'm going to make a blank 2 by 1 right here. 2 rows, 1 column, and this is definitely shorter than the last problem. Here's the first row, first column. So I'm going to multiply first row times first column. 5 times 10 would be 50. 6 times 5 would be 30. And then finally 4 times 2 would be 8. So that gives us 50 plus 30 plus 8 gives us 88. And then we need to fill in the second row, first column. So here's the second row, here's the first column. 7 times 10 would be 70. 3 times 5 would be 15. And then finally 9 times 2 would be 18. When you add those numbers together, you get 103. And it turns out, remember, this bottom team was the Running Cheetahs. The Running Cheetahs actually won that race, okay, with 103 points, or I should say won the meet, versus the Flying Falcons had 88. So that's an example of when you might set up some data in real life to use matrix multiplication. In future videos, I'm going to show you how to use some of those skills. We're actually solving equations with matrices. So hopefully this makes some sense.